Hello and welcome back to episode 2 of Software Engineering for Embedded Systems. This is project 2, serial transmission of temperature. And I'm just gonna briefly go over what I did, my approach for this project. And yeah, so let's get started. Here's my circuit. And it's using a breadboard, a thermistor, which is 10,000 ohms of resistance, and then a resistor of the same resistance, 10,000 ohms. This circuit is demonstrating a voltage divider, and those are commonly used to create reference voltages. So we can actually measure the resistance of the thermistor, which increases and decreases based on the ambient temperature in the room. So yeah, this red wire is connected to 5 volts, connected to one end of the thermistor. The other end is connected to a resistor of the same resistance. Orange wire is connected to the analog input of A0, and the yellow wire is connected to the ground. So that's basically it. And what I needed to do was write some code to convert the voltage that we're reading from this orange wire and the A0 analog input into temperature. And you can accomplish that by using the Steinhart-Hart equation and calibrating a couple values, which eventually outputs the temperature in Celsius and or Fahrenheit. So yeah, that's basically the circuit. I did need to make this configuration portable in order to put this whole thing inside my refrigerator. And the way I accomplished that was putting it on battery power and plugging it into that thing there, and storing the temperature and time associated with that temperature reading, storing those as a custom object inside the EEPROM, which is on this Arduino controller. And the EEPROM only has about 1 kilobyte of memory available. So after some math, that kind of comes out to about 21 minutes of temperature recording, which is enough for me because I needed only about 5 minutes of ambient room temperature recording and then 5 minutes of inside the fridge recording. The reason I have it on this cutting board is because moving around this circuit, it's just a sensitive circuit. The thermistor would sometimes fall out or whatever may be, and that messed with the readings on the EEPROM. So I had to keep it all kind of together in one place. Yeah, so the way it's configured now, I have it connected via USB to my computer, and I've already done the temperature reading, 5 minutes of ambient room temperature and then 5 minutes in the fridge. And so all that data is stored on the EEPROM. And what I'm going to show is just my program of reading from the EEPROM and populating it into an Excel file using PuTTY, which is pretty convenient. So this is just a basic program from reading from the EEPROM, incrementing it by the size of my custom data structure, which is 8 bytes. It just records the time and the temperature, and that's it. So we're reading address by address, reading the time, and then, so we're reading the time here, and then printing to serial output, time, comma, temperature. And that serial output is actually going to PuTTY. And the way I'm configuring that is doing serial, making sure this is the correct serial line, it's COM5, and then logging, I'm making this printable output to putty.csv. And it's really as simple as that. And when I open that connection, it should, yep, those are all of my values that are stored in the EEPROM. And it had an error writing to the CSV because I already have it open, and I've already done the processing of this data and graphed it. And I'll show you that now. What we have here is the CSV graphed into an ambient temperature over time, temperature being on the y-axis, time being on the x-axis in milliseconds. And I think it's obvious where I put this circuit in the fridge. So looks like I wait about 5 to 10 minutes, put it in the fridge for about 5 minutes. You can see those values go down to about 44 to 45 degrees. And it kind of maintains that temperature. And then once I take it out, it comes back up to room temperature. And that is that. Thanks for watching my description, and see you next time.